From Diamond Light Source, this is the Diamond Podcast.
Hello, Happy New Year, and welcome to this edition of the Diamond Light Source Podcast with me, Mira Senthilingam. We're kicking off 2012 with an insight into the cogs that make the synchrotron turn. We meet the engineers, safety managers, industries and directors that ensure that the electrons accelerate and light beams generate to enable the wide range of research taking place at Diamond.
There are the different divisions, of course, starting from finance, corporate services to communication, health and safety, industrial liaison, science division, technical division, accelerator people, and so on. And they all work together in order to achieve the common goal.
Diamond Chief Executive Gert Martelijk will be explaining just what's involved in running a synchrotron. And we also hear why the engineers keeping the machine running are so crucial, and also need to be quick on their feet.
Having a quick response is pretty vital because the machine being off costs quite a bit of money per hour. So getting the machine back up and running is our number one key.
So a good look inside Diamond, as well as the latest news and events from the synchrotron in this January edition of the Diamond Light Source Podcast.
The Diamond Podcast. For more information, look us up online at diamond.ac.uk/podcast.
At the Diamond synchrotron, electrons are accelerated at speeds close to the speed of light, generating beams of light up to 100 billion times brighter than the sun. So you can imagine that when working with such small particles and such high levels of radiation, the materials, machines and equipment, as well as conditions such as temperature and humidity, must be tightly controlled. To ensure this happens every minute of every day requires the expertise of many engineers and technicians based at Diamond, all with quite specific roles.
I'm Paul Amos. I am a senior PLC technician here at Diamond Light Source. I work in the machine protection group, which is a PLC-based group. PLC stands for Programmable Logic Control, and it's our job to make sure that the machine is safe to run, taking in vacuum levels, monitoring water flow and temperatures of vital equipment around the machine.
So you've mentioned the factors you have to monitor. How do they affect how well the machine functions and how healthy it is?
We just take the inputs in from a flow switch or a temperature sensor, and it's just a signal to say that it's healthy or it's not healthy. If the water flow was to dip, then that would compromise the temperature of a certain bit of equipment, which then could get even hotter and hotter. So we have to protect the machine from damaging itself. Therefore, we would first of all raise an alarm to say that the water had gone, and then if the water continued to dip lower, then we would trip the machine to protect itself.
And what's the ideal working temperature then in the machine, in the synchrotron?
We try to keep the temperatures below 50 degrees. Once you start to go over 50 degrees, then the electronics start to destroy themselves with heat.
And we're in your lab here at the moment, which is in Diamond House, so just over the road through the window we can see the synchrotron. Is this where you monitor all these factors from?
No, this is just a development lab. So in here we work on the ladder logic, which is the software that the PLC runs on. The monitoring is actually done in the control room via the EPIC software. So they log everything, all the temperatures, all the water flows, and we provide an interlock word which is displayed through the EPICs so they can then see what has tripped the machine off or tripped a valve closed.
And so what valves, I guess, are you controlling, and how do you set about controlling them?
The valves separate different vacuum spaces. So the beam travels around the ring and down to the beam line in a really high vacuum level. And we just have to make sure that the valves are safe to open, so that there's a good enough vacuum either side of these valves so that they can be opened to let the beam travel around the ring or down to the beam line.
And you've actually got quite a piece of machinery here. It's like it's a box, really, reasonably big in size, with lots of buttons on the front of it. And this is according to what it says, remote I/O valve control crate.
Yes, that's correct. It's the PLC, or Program Logic Controller, is within this box. It's one of our products. We have several other 6-valve controllers, 4-valve controllers, temperature control crates, and they are, as we like to put it, plug and play. So they are standard for Diamond, so that if one was to go wrong, which very rarely happens, we can easily take that PLC crate out, program up a new one and replace it, so we can be back up and running very, very quickly.
So you're quite you have to have quite a lot of technical knowledge, but also, I guess, be quick on your feet here.
Yes, having a quick response is pretty vital, because the machine being off costs quite a bit of money per hour. So getting the machine back up and running is our number one key.
And do you enjoy your role?
I do. The beam lines are always changing, new beam lines coming online, so they have new requirements, and we have new equipment coming in, so therefore we have to interface with new equipment, and it's really good. Really do enjoy it.
And how did you set about getting into this role? Because your path here is quite interesting in that you did an apprenticeship here at Diamond, training you up, I guess, in a variety of things, and you specialised in this. How did you get to this position?
Well, my apprenticeship was actually with the STFC, or CCLRC as it was back then, across the road at Rutherford. And I got there after doing my A-levels and spent 4 years there doing an apprenticeship in electrical engineering.
Interestingly, you also train the current apprentices.
Yes, Diamond have decided to help with the Rutherford scheme. In 2008, we started paying for 2 apprentices in each intake. We're into our 4th year now, and I'm charged with finding positions within Diamond in which the apprentices can come and learn new skills and fulfil their training needs.
Paul Amos, Senior PLC Technician at Diamond. Now, another crucial factor in a facility as large and as complicated as Diamond is the safety of the many staff and users visiting the synchrotron every day.
Hi, I'm Guy Thomas. I'm the Head of Safety, Health and Environment here at Diamond Light Source.
Now, Guy, there's quite a lot to monitor here. There's a lot of machinery, there's a lot of metal. It must be quite hard to actually keep everyone safe around such a variety of equipment.
Yes, you can split safety into 2 parts. You can split it into the inherent parts with the running of a synchrotron, and we've also got users bringing lots of samples and lots of different bits of scientific equipment to the site. So we've got the things that people introduce on a daily basis as well.
Well, we're currently inside the ring itself, the synchrotron itself, and we're on top of where the beam is, so it's currently going round just underneath our feet. So from what we can see here, what are some of the health and safety hazards perhaps that you need to keep an eye on?
Well, because of the complexity of a synchrotron, we've got practically every health and safety hazard there is. The only one we don't have here is asbestos, because we're a new building, but we're stood on above the machine, which produces radiation, so we've got everything from radiation. Around the side of the building, we've got laboratories, and you've got chemical risks in there, we've got lasers in there, we've got biological risks, you've got forklift trucks run around the edge of the building, so we've got issues with moving machinery. We've also got biological hazards, because we've got a whole village dedicated to biology, so the life science work. So we've got various viruses and bacteria that people bring here as well.
So what do you have to set about doing to ensure, I guess, all these samples and the machinery is safe?
It's mainly done by risk assessment, process of risk assessment. So the sort of static hazards, or the hazards we have on site all the time, are part of an internal risk assessment process, and all samples that come into the site are assessed by safety professionals to ensure that we can accept the samples and that the experiment they want to do is safe.
What's perhaps the most challenging thing to control?
Probably the most challenging and the biggest risk on site is construction. We're just starting phase 3, which is the building of 10 beam lines. Since the facility, the inception of the project, there's been construction work all the way through, and construction is by definition one of the high hazard industries in the country. Control of contractors and construction is the biggest one, yeah.
Now, I have to admit, Guy, I'm quite happy I'm inside the synchrotron with you because I feel like we'll only go to the really safe parts of it. How did you actually end up getting into this position? So I guess what made you become a health and safety expert?
My background is environmental science. I took the industrial route from environmental science into industry, the environmental route, and found that safety and health and safety is pulled together with environmental. I then learnt the professional side of health and safety and the two knit together. Before working at Diamond, I worked at manufacturing sites and worked in industry.
And what lured you into the area? So you have an environmental science background, but what really interested you into this particular aspect of it?
Well, you have to understand about biology, you have to understand about physical hazards, noise, lasers, radiation, work equipment, and you have to understand chemical hazards as well. So you have to understand lots about all of the sciences, or at least enough to understand what can harm you in different activities.
What would you say are some of the key traits people need to perhaps get into this career?
I think you've got to be calm. I think you have to be quite analytical in the way you think about things and creative as well. There are always new things that come up in safety, so you have to be prepared to go and learn about new things and come up with creative solutions. Otherwise you would end up stopping lots of things which you want to happen, but you just need to find a creative solution to make it happen.
And I just have a final question about your life outside of Diamond, really. And I guess, do you find yourself looking at the safety of things as you walk down the road or go into other buildings, and if something isn't particularly safe, do you think, no?
Absolutely. That is a curse of being a safety professional. You can't go on holiday without spotting the fire extinguishers in your hotel room, seeing that the lift is not safety compliant in hotels in Greece or somewhere, and yeah, you spot all these things even when you're on holiday and trying not to. Yeah.
So unfortunately, a never-ending busman's holiday for Guy. That was Guy Thomas, Head of Safety, Health and Environment at Diamond Lightsource.
Did you know that diamond is so powerful it produces more light than 100 million suns?
You're listening to the Diamond Lightsource podcast, and this month we're stepping away from the research taking place at Diamond to focus on the machine itself and the hundreds of staff needed to keep it safe, working and attracting scientists to its beams of light. Still to come, we meet Diamond's chief executive to hear how the synchrotron is run from the top down, and we hear how industries and companies are making use of synchrotron light. But we can't let a podcast go by without some news on the research being conducted. And so first we join Sarah Boundy for a roundup of the latest news and events at Diamond.
So we've had some research recently published in Nature Immunology. A number of Diamond's life science beamlines have been used to study killer T cells in the human body. These are cells that help protect us from disease. So a team from Cardiff University and King's College London discovered that T cells can inadvertently destroy cells that produce insulin. And their findings provide the first evidence of this destroying mechanism in action and could offer new understanding of the cause of type 1 diabetes.
So how did they actually study this whole area?
So the team isolated a T cell from a patient with type 1 diabetes so that they could view the unique molecular interaction which results in the killing of insulin-producing cells in the pancreas. So now that they've got the evidence of this mechanism in action, they can actually see how killer T cells might play an important role in autoimmune diseases like diabetes. So this knowledge can be used in the future to help researchers predict who might get the disease, but it can also help to develop new approaches to prevent it. For example, catching the disease early before too many insulin-producing cells have been damaged.
So also quite important because it's a disease that's becoming quite prevalent today as well. Now, stepping away from biology and more onto chemistry, and in particular molecular chemistry.
Yes, so Diamond's small molecule single crystal diffraction beamline, I-19, has recently played a key role in helping to reveal the exact structure of the most complex non-DNA molecular knot prepared to date. So knots are found in DNA and proteins, and they're even found in the molecules that make up natural and man-made polymers. and they can actually play an important role in the substance's properties. For example, up to 85% of the elasticity of natural rubber is actually thought to be due to its knot-like entanglements in the rubber molecules chains.
Why did chemists or why do scientists want to study these in particular?
So they're interested in studying the molecular knots to understand how the knots affect the material's properties, such as elasticity. But tying molecules in knots is something that's really difficult to do, and up until now, only the simplest types of knots have been achieved. But recently, a team from the University of Edinburgh succeeded in preparing a molecular pentafoil knot, which is basically like a 5-pointed star. The scale that they were working on was 80,000 times smaller than a hair's breadth. And they brought that molecular knot to Diamond, and the National Crystallography Service collected the diffraction data. And an academy professor from Jyväskylä University in Finland solved the structure.
But what would, say, some of the applications be then, having discovered this?
Well, being able to produce materials with a specific number of entanglements rather than the random mixture that occurs in present plastics and polymers, it could actually allow scientists to exercise greater control when designing materials. So, for example, it could lead to the creation of very light but strong materials, a kind of molecular chainmail. And it could also produce materials with exceptional elastic or shock-absorbing properties, because molecular knots and entanglements are intimately associated with those characteristics.
Now, as well as research, though, as usual, the users of Diamond are actually quite important, as well as the beamlines, and there have been first users on one of the more recent beamlines.
Yes, so this is our 20th beamline to come online now. It's Diamond's X-ray imaging and coherence beamline. It's welcomed first users towards the end of last year. Researchers from the Universities of Manchester, Sheffield worked with the beamline team to develop techniques on the coherence branch of I-13. So I-13 is our long beamline, which stretches 250 metres away from the X-ray source within the synchrotron building.
Now, in previous podcasts, we have discussed why this needs to be so long, but for anyone that didn't hear that, why does this beamline need to be that extra distance?
Well, the distance is necessary in order to produce fully coherent light, and that's light considered in its waveform as opposed to particles, and that enables a wide variety of experiments. So as the light travels over the distance, it fans out into a large lateral coherent beam, and the beamline receives very brilliant light, which can be described to have laser-like qualities.
And what were users looking into?
So the users were using a variety of samples as a means to test the beamline's capabilities. The Sheffield users are working on a pioneering technique called tychography, which basically involves exploiting the coherent light in such a way that they are able to combine diffraction and image data to create a high-resolution computer-generated image of their sample, and that's at the nanometer scale.
Now, as well as people coming in to use the facility, though, Sarah, there's quite a big anniversary coming up for Diamond.
Yes, 2012 is actually Diamond's 10-year anniversary. So the joint venture company was formed a decade ago in March 2002. So we'll be celebrating throughout the year with special editions of our newsletter, public open days, along with a number of added extras to highlight Diamond's many achievements over the past 10 years. Keep an eye on our website to find out more.
Thanks, Sarah. Sarah Boundy from Diamond's communications team, who'll be back in the next edition with more news from Diamond. But if you can't wait until then, visit diamond.ac.uk for more news stories and multimedia content. Now, moving back to the people that keep Diamond going, we meet the man at the top, Diamond's chief executive, to discuss just how you run such a large particle accelerator.
Hello, I'm Gert Martelik and I'm the chief executive of Diamond Light Source. I have started with the company from the beginning, planning it, building it. We now have more than 400 employees. And also after building the experimental installations, we then started operations, producing science really and studying things with a broad variety of different scientific fields. And that's where we are right now.
So you're well and truly rooted in the past and future of Diamond. So could you tell us more about the culture of Diamond, really, the types of people you have working here and the variety maybe of departments and disciplines?
Yeah, it's wonderful to work with all kind of different people. I mean, if I say we have more than 400, that doesn't include our users. We have more than 2,000 different users coming to us from all over the world. And this year we have celebrated the United Nations of Diamond every week a different nation. And it was great.
And what about the people actually housed here at Diamond on a regular basis? Because there's quite a variety in the actual roles within. So there are people doing research here, perhaps there are engineers here. There's such a variety of actual positions here at Diamond.
Yeah, there are the different divisions, of course, and starting from finance, corporate services to communication, health and safety, industrial liaison, science division, technical division, accelerator people, and so on. And they all work together in order to achieve the common goal.
And what about your role here at Diamond? So you're the chief executive. Currently, you're really, I guess, having to overview quite a wide range of different scientific disciplines and different areas, fields of science taking place here. But what's your actual background? What scientific origin are you from?
I'm a physicist, really, and my special field was surface and interface science, physics. So that's where sort of reactions are really happening. Life wouldn't be here without interfaces and surfaces, really, because that's where it all started. Then I learned about the synchrotron light very early as a PhD student, when I once heard a talk of now famous physicist from Spain, and he described synchrotron radiation to me in a seminar, and I was immediately on fire and said, that's what I want to do. I went to my thesis advisor and said, I want to go to what was then Hamburg. That was the only synchrotron, and I want to play around with this light. It's relativistic light. It's wonderful. I want to see it, really. And that got me triggered.
And hooked you.
And it hooked me. There's a saying in the community, once you got the synchrotron virus, you never get rid of it.
And so I guess now your role involves spreading this synchrotron virus to the people that work here at Diamond, but also outside of Diamond to get them in for various, perhaps the trainee schemes and PhDs that are on offer here as well.
Yeah, I don't see it like spreading a virus. I really think they love to get it. I'm really always pleased to see students and young students, and we also have school classes visiting the Diamond, and I love to see them and asking then on an open day a youngster, what do you want to be at the end of your life? And he says, a scientist for sure. And I don't know any scientist who really regretted to go into this field, and that's also true for technicians and for engineers. And I think even people in administration supporting the scientists, they get part of the virus as well.
And just lastly, I guess, what are some tips then that you give, or you would give, to these pupils that you see as they come to visit Diamond, or perhaps anybody else that is contemplating a career in science? What are some suggestions to help them advance in this field?
First thing, they should always do what they like to be doing, and they shouldn't be scared. It's like learning to play a piano. Yes, you have to practice. And if you don't practice, you will never play the piano well. And it's the same in science. You just have to practice, you have to learn things, and at the end, then you can apply these things. And that's what we are doing. So just look at it and don't be scared. It's wonderful at the end.
Gert Martelijk, Chief Executive of Diamond Light Source. Now, that's almost it for this month. But before we go, having heard how the synchrotron is kept safe and running, we now hear how scientific industries come to hear about the facility and how they set about using it to research and develop a diverse range of products.
Hi, I'm Claire Pizzey. I'm an industrial liaison scientist here at Diamond. My role at Diamond is to help companies who want to use the facilities here at Diamond. So I work in a team of scientists who help scientists in industry access the facilities at Diamond for their own research.
And what kind of industries do want to access Diamond?
A whole range. We have facilities that offer a wide range of different types of science, and that matches up with a wide range of different types of industry, ranging from pharmaceuticals through to catalysis and chemical companies, through to engineers and anything and everything in between. For example, we've done some work with Johnson Matthey, who are a chemicals company. We've done some work recently with Heptares, who are a biotechnology company, pharmaceutical company. Quite often companies are developing new products, or they're trying to understand their existing products better, or they're looking to ways to make them even better than they currently are, and that's why they look to find a range of research tools, and I think that's what they find here at Diamond.
And so what are perhaps some of the key parts of your role aiding this liaison between them?
I'm one of a team of scientists, and we all cover different subject areas or technique areas. So my specialty is scattering techniques, so predominantly small angle X-ray scattering, but I also do some surface scattering measurements. Small angle scattering and surface scattering are techniques that allow you to look at the structure of materials, whether that's the structure of a bulk sample or the structure of materials at interfaces. Now, those are quite important in a wide range of types of products in different areas, and so that can be applied to many different situations. So my job has a couple of different elements to it. I work closely with my colleagues to try and perform some of the research that we do on behalf of companies. So it might be that companies want to come and do their own research, and they come and do their own experiments, much like our academics users do. But in some cases, they prefer it if we do the research on their behalf. Then it might be me or my colleagues who do the experiments for them, analyse the data and write them a relevant report.
So that's quite a nice varied job role, really, I guess. You get to see the kind of research side of things and the experimental side, but also the more office-based stuff and meeting people as well.
I really like my job. I think it suits me very well. I get to meet lots of people. I get to talk about high-level science. I mean, I'm not publishing as much anymore. A lot of what we do is obviously under confidentiality agreements. But what I find is that I get to be involved in projects in a wide range of different industries, in a different range of, let's say, end products. It could be drug discovery through to like a shampoo type formulation, through to some kind of engineering component. And I like being able to see how we can use the techniques at Diamond to help across such a wide range of different research problems.
And how did you get into this area of work, I guess? So you're conducting experiments yourself, so you must have quite a strong scientific background.
Before I joined the Industrial Liaison team, I was actually a member of the scientific team on one of the beamlines here at Diamond. So I did my PhD at the University of Bristol. I was then a postdoc in the States for a couple of years, and then I joined Diamond in 2008, working on the small angle scattering beamline I-22.
And what specific area of science did you focus in on before, say, during your PhD and so on?
Well, my PhD was quite interesting. I was industrially sponsored, which I think has made me really appreciate and enjoy applied science. So I was working on display materials. So I was sponsored by Hewlett-Packard, and we were looking at trying to make novel display materials. Now, unfortunately, what I was working on my PhD didn't end up working, and I'm sure it's not a product, but it was really interesting, and it led me into this field of small angle scattering, which is what I've done a lot of ever since.
And just lastly, really, any tips for people that are enticed by the sound of your job and want to go in that direction?
Well, I think that fundamental training as a scientist is very useful for the job that I do, but I think also with science you can't always predict where your career will take you. And so you have to really start with what you're interested in and keep doing what you're interested in, and it will find you.
Some top career advice for all budding scientists, courtesy of Diamond's Industrial Liaison Scientist, Claire Pizzey. Now, that is it for this edition of the Diamond Podcast, but do join us again in March as we return to the research and bring you more news and insight on the science taking place at Diamond. In the meantime, if you have any questions about Diamond, email podcast@diamond.ac.uk. You can also listen to previous editions of this programme online at diamond.ac.uk/podcast or nakedscientists.com/diamond. You can also find the Diamond Podcast on iTunes. Thank you this month to Paul Amos, Guy Thomas, Sarah Boundy, Gert Martelik and Claire Pizzey. I'm Mira Senthilingam. Thank you for listening and see you in March.
The Diamond Podcast is brought to you by Diamond Light Source and produced by thenakedscientists.com. There's more information on our website at diamond.ac.uk/podcast.